Okay, today's talk is a bit off the beaten path for me. Usually I like to get into the intricates of Kotlin and architecture and Android. Um, but let me share my screen quick here. Does this work? Yeah. Yeah, like I was saying, I usually talk a lot about nuances around Kotlin, coroutines, Android stuff. Um, and the Gaussian blur is definitely not, specific to Android or really any industry at all. But it came up a lot while I've been at Microsoft just because our designers only look at iOS, and then our CEO, the chief, leadership people, they all they look at is iOS, and they keep asking for blurred content, right? And so when you think about blur on iOS, you get it very, very cheaply, and pretty much out of the box. So for about 2 years, I kept getting asked like, why don't we blur this screen on this like 30 FPS live view behind it? And it was a constant battle of like, we can't do that easily while also supporting, APIs back to SDK 22. So I just wanted to take it upon myself to dig into more of what the blur is, the mechanics behind it, and what it kind of looks like today in modern Android, and kind of compare it to iOS. I'm glad we have a Swift person, I guess Dave is also formerly Swift as well. So would love to get more details behind it. I'm by no means an expert. Like first and foremost, this is purely exploratory effort, and I thought it came together pretty cool in terms of what it really means to blur a screen, for what we all see today. So yeah, again, if you have any questions or any input, I'd love to hear everyone's insight. If you've done something similar or if you've worked with it, let's talk about it. So alongside work kind of annoying me about like wanting to blur everything all the time, I've also been a big fan of this channel on YouTube called Three Blue, One Brown. He's a big math guy and he does a lot of animations, and he did a whole series on convolutions, which is like matrix theory, linear algebra stuff. But he dips into the Gaussian blur for a large part of that whole series, in which kind of like started to click a little bit more in my head as to like what makes it difficult on specific platforms. So I'll get into more of what these images really mean in context here. Um, but at the end of the day, the Gaussian blur is really just the bell curve we all knew, coming out of high school and then like higher level college classes. You'll learn a lot about it with standard deviations. It kind of reflects basically any data set, like literally any data set you collect. It will take some shape of a bell curve, and you can pull away lots of details from that information. But outside of math, it's used a lot in graphics. Obviously, that's where we're going to be talking about today. When you soften image and you make it smoother, like when you think about segmentation and edge detection in graphics, it's also a big part of that because you can kind of tell like differences between one color and another. You can start to make judgments based on what is the edge of an image. And quality control, obviously, that's part of the bell curve. If you're so many deviations away from the mean, you could probably start to assume something's wrong or something's really good. Um, and then yeah, it goes into physics. A bunch of industries dabble with the bell curve. Um, and this image kind of shows also a screen grab from this video. No original content here. Sorry. Um, this is a screen grab of the convolution that's happening to make an image blurry at like, this is a very low pixel image, and you can see that little blue square is kind of the visualization of what's going on at the rendering level. Um, and then on the right image, you see the output. Again, we still don't know a whole lot of what's going on here, but that's what this next slide will do. Skipped it here. So yeah, that blue square. So again, we're thinking about this blue square on this screen. That blue square is depicted here. And what's happening is it's taking all the immediate neighboring pixels, and then given their distance from the center, they're giving those colors and those pixels a specific weight, right? So this is an interesting scenario where this is the blush pixel on that squirrel or dog, whatever it is. And it has the highest weight for the resulting color on the right. And essentially you can think of this, 2D array of static values that says, okay, the pixel that is two steps above the center one is given, 0.022. And you see the same 022 here, here, and here. And you can kind of visualize what that Gaussian blur, 3D graph would look like, but this time it's in a static 2D array. So every single frame, every pixel goes across this convolution, and in um, this top graphic here kind of shows what the math is. You weight each color and then you add them all together, and then that pink actually convolutes to more of a tan color at the end, which, going back to the prior slide, you get that blurred image that we all know and recognize. But behind the scenes, this is exactly what's going on. So again, every single frame, every single pixel goes across this calculation. So you can kind of tell that, I mean, you could probably imagine too, the bigger the radius, so that's what this red circle is, the more weighted values you have to calculate, the more time it's going to take. Whether you're doing it on the CPU or the GPU, obviously the GPU can do it much faster, and we'll get into that in a bit. Um, so yeah, I guess I left a couple tidbits here about what it's doing behind the scenes. But essentially, the further away you are from the center pixel that you're evaluating, the less influence you have on the center. And that, again, that's kind of looking like that 3D bell curve we saw on that first slide. Okay, nerdy, academia stuff aside, back to our mobile world. Like when you think about Android versus iOS, let's start with the iOS side on the right. iOS has made blurring a first-class citizen, and iOS gets the advantage of owning every single piece of hardware and obviously all the software that runs on all of their devices. And since API 7 or 2013, 10 years ago, it's been a big part of their design language. And that you get it out of the box for pretty cheap using their metal APIs. And again, it's a first-class citizen when you start talking about their rendering pipeline. And again, if there's anyone that has insight on iOS side, I'd love to hear more. But I just have some tidbits here and there. And on the Android side, you actually see blur sneak in some very curious ways. Like I have a screenshot of YouTube, and they've recently updated their UI to have this like background blur going on that updates, I don't know, like every few seconds or so, and it's like a slow update, like kind of grabs a frame, and then you can kind of tell. This is actually a really bad example. Now that I made this slide, I've seen some pretty good videos that show drastic color changes, but you can see the subtleties here where they're like, oh, this globe is a big part of the color, so it's that's part of the blurring going on, and then this window in the background also played a big role in that resulting blur. But it's like a very big radius, so there's no like details you could pull away from it. So this is just one example. I think Instagram has some blurring mechanisms going on. They used to have it so that their sticker drawer would constantly blur the background even if your camera was on, and you could tell that it was running at like 6 or 7 FPS because it was constantly having to update that background blur. They don't have it anymore, but there are some other examples, and it's kind of interesting to see how some apps integrate it. But largely, it's just not a first class, feature set in the design language of Android. Um, and that's from the research I've done. Obviously Android runs on thousands of devices with a multitude of kinds of hardware. So the GL language has to cater to all of that and kind of be generic enough and efficient enough to work on any device that decides to run Android. And I cannot find any documentation from the Android team themselves, but it's never been a first-class citizen in any capacity outside of like hand rolling your own solution in the shader world of graphics. But in newer Compose APIs, there's some blur properties that you can start using, and I'll show that off in a second here. So it's interesting, like the bad thing about like designers is that when they think about blur, I guess I'm really talking about my designers. I'm sure all your designers are great. But when they think about blur in our world, they specifically think about not blurring an image. They want to like blur the background of like a dialogue, but they want that dialogue to be opaque so you see through it, and then you blur the content that you see behind that dialogue. You know what I mean? So that's kind of depicted here in these two screenshots. There's a floating dialogue of some sort. and it's opaque, and the image that shows through is actually blurred here and there. It's like Samsung has some good mechanisms in their OS where they get blurring pretty quickly out of the box, but none of it's like first party out of the Android SDK. So when you think about like blurring content, absolutely. Like give me an image, I'll blur it, no problem. Like blurring content behind a translucent window, again, iOS gets it pretty cheaply. Android, you have to start doing some fancy things where you like take a bit app, excuse me, this pop's making me burp. You take like a screen grab of the content behind something and then blur that. And I don't know why I put API 31 else difficult because it's still annoying. Like it's all the pre-work to get whatever's behind that content. And then you start getting into like real-time blurred content. Sure, like you talk about like a video feed, right? You can use the shader to run that blurred code on each frame. Like we do that in my position for the project that we work on, no problem. But then the ultimate like design choice that we see a lot is they want to like shade the background of an object over a like 30 FPS screen running a video and have that be very efficient and fast and like be a part of the design language. And I have yet to see a good example of that in any context. Outside of like again, Samsung's OS gets away with it pretty good. I don't know how, but like that's often what I have to deal with, which has kind of inspired a lot of this conversation in the first place. Um, okay, so I know we have some iOS engineers in here, and like we all know about that, the thin material that you kind of just get a tack onto your view, and bam, it's there, and it even works with content that's working at 30 FPS. It's constantly being updated. There's no real overhead to think about. And I know I'm like kind of teasing here that I'm going to get into what that would look like in the Android world, which I had full intentions to do so. But I ended up spending so much time that I was like, we'll just show what, kind of blurring looks like in Android. So I still want to dig into it and see what a good real-time blurring the background of an object hovering over a 30 FPS video or camera feed. But let's dig into just some ways you can blur in Android today in the compose world. Where am I at here? Okay. So some context. When we think about blurring, I was messing around with some of the bitmap mechanics here, and it's not what I thought it was going to be. When we think about blurring, a lot of the APIs from Android used a thing called render scripts, which was like a step above the OpenGL layer of like working with a surface view and applying shaders to whatever content's in that view. But you can see that it's already deprecated, right? Classic Android. So we're going to look at what the deprecated render script code and how that operates, how fast it is. And then we're going to look at what they recommend using their Vulkan toolkit library, which is a C++ NDK that you have to load in as a side module. And then we'll look at like the first party modifier tooling we get out of Android today, which is just like similar to the thin material in iOS, but it's just called Blur. And but it's only supported at API 31 and above. So we have a long ways to go before we can even think about using that all the time. I'm just going to get my phone spun up here. Stamp Zoom preview here. Okay. Get rid of this preview again. Okay, backing up a bit. So we have the legacy approach here that I think I have it called CPU on the UI for some reason. Again, the legacy approach is using the deprecated render script approach, which is kind of what Toolkit uses behind the scenes. And they actually recommend to use render script for blurring specifically for whatever reason. You should really consider looking at their documentation here when they start talking about migrating from render scripts. Here's some things you can do, and then here's like a library on GitHub you can follow. And that's exactly what I did. And they have some nice sample code here, but yeah, I'll send those links in the chat later. So again, this first option is the render script. And you see it's kind of fast. And actually, once you get up to a certain blur radius, and that seems to not working because I just ran the old code, I think. Okay, that is working. All right, that's working again. Okay. So once you add more, so what I'm changing here on the slider is the radius. And again, the radius is how large that Gaussian or that bell curve is, that 3D bell curve, and how many pixels you're taking into consideration. So as you increase that radius, the more pixels it has to consider to impact the resulting pixel. And what's interesting here is that like I can go all the way to the right and it's not that blurred, like this is like it, there's not many pixels influencing the pixels that we're, resulting with here. And you can already tell that it's starting to lag on, it's lagging on my own end here too. Usually it's not this terrible, but we start jumping up to, hundreds of milliseconds. And again, it's not even that blurred. So then the other option here is what I called Vulkan on the UI, but it's actually just, it's that toolkit. It's that native development kit that Google suggests to use now to do blend among other things like LUT tables and resizing and like color matrices and stuff, which I didn't do. And that is a little faster, although it doesn't seem like it. Yeah, we stay just south of 200. Sometimes it peaks above. Disclaimer here, both of those actions, both the CPU and the Vulkan, are like needlessly creating a new bitmap each time, which I was going to try and fix before this talk, but I'd be interested to see what the real computation time is, if I didn't have to like force them to create a new bitmap each time, because that is one of the most taskly things you can do on Android. So you see like every single time I move that slider, it has to create a new bitmap. I could just have a static one. Anyway, so back to Vulkan. Again, Vulkan is the recommended way to do image editing now from Google outside of, hand rolling your own GL script. And it's pretty good. And obviously most applications you're not doing like real-time blurring. So like as I slide this, there's dozens and dozens of new values getting hit, and I could probably have it not do so many at a time, or like do it on a background task or something. But you can tell that it is clearly dragging on the UI. And the CPU one's a little worse, it seems. And I have some notes in my code here, which is helpful for the talk. So again, yeah, legacy approach is using render script, which can be the CPU or GPU, depending on the device. And then the Vulkan approach, get rid of this window. Like the Vulkan approach is a little faster, but even Google says it may not work on all devices. And it will also decide to use the GPU or CPU depending on the device. But it uses like native code to run that shading logic. And then the last one, the fancy new first party modifier code from Compose is just the blur. And there's like, this is straight from their SDK. And you kind of see what they're doing here. They spin up a graphics layer to run this blur effect. This blur effect is, I think it is still like a render effect behind the scenes, but for whatever reason, it's extremely fast. Yeah, they use render effect behind the scenes. So like, why can't we use render effect, but they have their own internal render effect? It's kind of interesting. So let's see what that looks like. The comp time on here isn't accurate because I had no way to wrap how fast it could, complete the compose. I guess I could probably get fancy with how compose exposes that stuff, but the comp time always shows 0. But you can see a couple things. It's really fast. It's like, it feels instantaneous, right? The other thing is that I can jack this 25 radius here is extremely blurred, and that's coming straight out of the compose world. So it's really nice to see that they're starting to focus on these things. I have no idea what this looks like when I go back to the scenario where you need to blur 30 FPS, but only a subsection behind a content window, and that content window might move in real time too. Like think about like a drawer moving above like your camera feed, right? Like if you could blur the background of that drawer, how do you grab that specific section of your camera feed, blur that, and then display that on the render thread? That'd be the more interesting demo, I think. But this is still pretty cool to see it like a few different ways to do it. And in the Android world today, there are a couple other options you have. Um, I've been working on this OpenGL, like a true shader approach from, the nuts and bolts of GLSL, and I haven't got that working yet in the context of compose. I might have to just do a non-compose example. And then there's this Android GPU image, which I'm sure David recognizes, which is a third party that's been sort of widely supported to mimic what iOS gets out of the box. I have it pulled up here somewhere. And you see this in a lot of code bases. Like you see a lot of bits and pieces of like GPU image and like GL surface view. Like I'll tell you that the freelance job I do for Lens Distortions, which is a massive photo editing project, they use this source code, and my Microsoft job, which deals with um, video creation, uses the same exact code. But a lot of times they just yank it and then change it up to do specific things. But this also does a ton of functions here. So you see our blur somewhere there. Yeah, they have a bunch of different types of blur, the Gaussian, and then your LUT tables and all these other filters, which really sets it far and above this new toolkit library that Google suggests. So at the end of this whole story, it's really just that Google's never leaned into the graphics layer nearly as much as they've done on iOS. iOS has a lot more tools and first-party tools to use. That makes it way more difficult in the realm of Android. Um, so hopefully someday we get something that's similar to like Metal in iOS. But yeah, that's basically it. Just a few approaches on Blur, and hope you pulled something from this. I would highly recommend watching that video from Three Blue, One Brown about convolutions, specifically this Gaussian section, which I think I have linked. Oh, not the timestamp, but I have the video here. I'll put that in the chat. But yeah, any questions, comments? I'd love to hear if anyone's ever dealt with like blurred designs, static images, live content.
I have not, but have so your work, or maybe some people are suggesting that you integrate some of this in your app. What would be your technical recommendation based off of what is available for you? Like if you were trying to sell your boss, like I don't want to do a whole bunch of work here, or maybe I do want to do a bunch of work here, do it the best way. Like which one of these approaches would you sell it on, or would you sell it on nothing?
Uh, I would make a presentation and then show it to him. No, I'm joking. Actually, I did make this presentation for my day job, and we have like an engineering group that we chat. But that conversation came up a lot. And then my boss is a web developer, and they get first party blurring content out of the box as well. So he was always opting towards the side of like, you should just be able to do it. I'm like, but like, do I need to like write a demo and like do a presentation just to show how hard it is? And like some people just don't get it. Like honestly, it always came down to like our tooling. Like there isn't tooling to support that on a wide variety of devices. And even if we were to make that happen, it would hog the battery and it would make your phone hot so much. We actually did build a like example app last year that tried to do that like live, give me the background, blur that background, and then place that background on a floating dialogue. And it was like 6 FPS. And that was the only way to really get them off our back. Be like, hey, designers, like I see you're blurred here, but we're just gonna make like a gray opaque background or like something that's lighter that mimics it. So there's really no good end of that conversation, especially when you have people that only look at web and iOS. It's a never-ending battle. I know Android engineers feel that everywhere.
Yeah, I imagine the reason why it works well through the new compose way is because they're not doing Gaussian blur the way you're supposed to do Gaussian blur. They're faking Gaussian blur or something like that. If you probably look at the code, they're probably doing some sort of crazy mathematical theoretical thing that's like unless you're deep into that stuff, it's hard to replicate.
Yeah, I mean, you,
Graphics layer is like a function and modifier. And it's a scope. They have a graphics layer scope, and it says use that to the apply effects and stuff that has nothing to do with anything above it. Or whatever, so it's like, I almost wonder if it's running on GPU or something where that can freely calculate. Because that would make sense to me. And then they have create blur effect, which I drilled down and it just ended up into a, like
Yeah, you're the NDK world at that point.
a what?
I
NDK?
guess no, this is the API level. So it's, unless I have it downloaded, you can't see it. It's hard to tell exactly what they're doing because like this render effect library is the exact same thing that is deprecated, named differently. Or I guess render script is what is deprecated now.
The ability to do it, it's just they haven't quite utilized the chips, like the graphics processing, because I mean, again, games do it all the time.
I think I've heard them talk about it on like the like Google Android podcast, and they say that they specifically left this out because it's a hard problem to solve. Like from my understanding is it's like to solve this, they probably don't use the same blur code that other things use. They like kind of hack it or something like that. I've heard them. I don't know if I could find the exact podcast.
I'd love to listen to that.
I'm pretty sure they talk about it on the what is the Google one, the main Google one. Let me see which one it is.
There's a main Google podcast.
ADV. It might be ADV. Let me see which one. I listened to like all of them, even though that even though a lot of them are garbage for me. It's called Android Developers Backstage. So if you go through that, you'll probably they have a lot of people there that are basically people who work deeply into graphics. It's crazy the stuff they talk about. And they'll like kind of like mention like stuff like this sometimes. So
Oh yeah,
it's
that
kind of
Romaine guy
yeah,
is very smart.
like and they talk about they what they do is they fake things to make you have effects for things. They don't do actually Gaussian blur. They give a Gaussian, maybe like hypothetically they might give a Gaussian blur looking light thing, but it's actually not a Gaussian blur. It's like some hack and be a Gaussian blur. And maybe that's the same thing that Apple does too. Like in web too. Like it's like all theoretical crazy stuff that's like not following like what Photoshop does.
Yeah, I mean, there's tons of different types of blurs. Like Gaussian is just a way to distribute the influence. But I'd be really interested to see what they had to say about how they faked it. So it'd make more sense to me.
We talked about blurs before, so if you could find that, so that would be good.
So you were saying through the API, you can't like really write and apply your own I forgot the word for it. What is it where you actually write the input output formula for each pixel as it comes through the shader, right?
Yeah, the shader. Yep.
You can't write your own shader using the API, right? You'd have to get like lower level than that.
Correct. Yeah.
Okay. Because I was thinking about it, like obviously this is a hard problem that people smarter than me have not solved yet, but like with Gaussian blur, because part of the problem is the sampling, like you could still sample the same number of pixels, but just change the distance. You would just end up getting like a slightly pixelated blur, I would think, right?
Yeah,
But
you
then
can. Yeah, that is a type of blur style you see where it looks more like gamey, where
yeah,
that I know what you're saying.
yeah. So maybe that applied with like an opacity or something could like give you a little bit of that cheat. As far as like the frame rate thing, like even I guess you could try like less sampling less frames, but I don't know why I'm I don't know, like I'm just kind of thinking out loud about it. Because I mean, like I don't have to deal with this level of stuff most of the time, right? Like I'm like the app has to do this thing and grab this data and show this. Um, but and on of course the web world, it's like just CSS properties. It's like
Right.
but that's really interesting, like just like the mathematical sampling involved in that. And I played a little bit with the shader area of it, just like playing around with Unity, just like screwing around trying to like make a game or whatever. So yeah, it's really interesting. Like, have
The
you?
WebGeo world. Sorry, I didn't mean to
No,
interrupt you.
no, go for it.
So I work with a guy who is like a GL expert at Microsoft, and he handles all the GL stuff for the website. And the cool thing about WebGL is that there are tools on web that let you interact and visualize and see what's going on in the geo world in a very similar way that like the developer tool set does in like Chrome. Like any browser has that developer tool, so you can like analyze HTML and CSS. And there's a similar tool on web that lets you do the same thing for GL. So you can like tweak in real time what's going on to like interact with the shaders and
Oh,
make
that's
sure
cool.
things are working. Whereas like Android, that shader code gets thrown in as a string. So I don't have any example here.
You
It
have to
gets
like
thrown in as a
compile.
string.
Okay.
Yeah. And that gets compiled at runtime. And then to analyze errors that the shader might run into, you have to like say, hey, give me an error for this error code if it exists. So there's nothing like spoon feeding you what's going on. And I
Yeah.
really wish I had a good example because we deal with shaders a lot in both my day job and some of my freelance, which is just like a big black box. Like there are people who are experts in this field, and then I kind of stay high level and like tweak things as needed. But it's a very scary world. But at the end of the day, it's important to know that if you boil every little view you work with in Android, you boil it down to the nuts and bolts, you know, it's working on the same GPU layer and it's working on the same shader layer as everything else, but it's all obscured away in that like nice high abstraction that we all love. Um, so it's crazy that like it's so hard to understand it, yet we work with it every single day, whether we know it or not.
Yeah. Huh.
Sorry, I'm still sharing my screen here. I'm just messing around with stuff.